Welcome to the Bee's Knees, a podcast wild about native bees. Wild and native bees are under threat worldwide. In each episode, we look at actionable things we can do to support these adorable little guys whose pollination work is crucial for maintaining biodiversity. I'm JC Meyer, and I thank you for being here. What if the danger isn't a bee dying, but a bee simply not coming back? That's the idea behind a new study looking at prallethrin, a common insecticide in household products used to control mosquitoes, flies, cockroaches, and ants. It can be found broadly in electric vaporizers, mats, coils, and aerosol sprays. Dr. Kimmo Kaakinen and his team in Finland exposed bumblebees to prallethrin for 1, 10, or 20 minutes, then released them 1 kilometer from their nests. Over the next 3 days, the team watched to see who made it home. The pattern was stark. In the control group, 37% returned. A 1-minute exposure didn't change that much. But after 10 minutes, only 17% came back. And after 20 minutes, just 5%. The longer the exposure, the more likely the bees were simply lost. So what's going on here? Let's talk to Kimmo. Can you tell us a bit more about the insecticide you studied?
In this current study, volatilized prallethrin impairs the homing ability of bumblebees. We studied volatilized prallethrin. Prallethrin is a pyrethroid, a synthetic insecticide used to repel or eliminate insects. Prallethrin is a neuroactive agent that causes a channel inactivation and prolonged depolarization in sodium channels in neuronal membranes. Prallethrin is used in many insecticides against mosquitoes and wasps, for example. In Finland, where I'm from, it is used in 11 insecticide products. Most well known of them is Thermacell portable mosquito repeller. This Thermacell is a consumer-grade device that heats prallethrin mats, and it creates a cover area around 20 square meters free of mosquitoes. And this Thermacell device was the one we used in our study. This Thermacell device is very popular, at least in Finland, and compared to repeller candles, for example, it's very effective and it does not smell bad. But a few years ago, there was a huge conversation when some environmentalist mentioned that this device that vaporizes neurotoxin is maybe not so good for other insects either. This conversation continued every spring, but there was surprisingly few studies with volatilized prallethrin. So in 2024, when I was done with all field experiments for my doctoral thesis, I had some extra time, knowledge, and material, so I decided to put them in good use, and I collect this data used in our latest study.
So you've done a lot of research into herbicide exposure and wild pollinators. In this study, you looked at homing ability as a behavioral trait. Why is navigation such a sensitive indicator of sublethal pesticide effects? And what might impaired homing mean for colony-level health or survival in the real world?
But navigation is an important ability for bumblebees. Bumblebees have to forage food and they must return back to the nest, sometimes from long distances. If the return time is delayed, or worse, if bumblebees do not return at all, colony might confront food shortage, which can negatively impact colony fitness over time. Colony doesn't necessarily die, but it might cause, for example, decline in drone or queen production, which might lead to long-term population declines. And navigation was only one option we could study. I have written articles about bumblebees and glyphosate, where I studied the effects of glyphosate to, for example, memory, learning, and gut microbiota of bumblebees. But because we kinda only had one shot with this, I wanted to study something where the possible negative effect is very easily understandable for wider audience. I mean, it is easier to understand why it's bad if bumblebees do not return back to the colony after a prallethrin exposure than understand why it matters if bumblebees cannot learn colors as fast, for example. Also, if I'm being brutally honest, I wanted to do something outside rather than in lab, but please don't tell anyone. But as I said, the navigation is only one important ability that prallethrin or other pesticides might disturb. And this was only one study. For lawmakers, for example, it would be important that there are lots of articles studying this question. So I encourage other scientists to study this theme as well.
Many people, lawmakers, myself included, assume domestic insect repellents are harmless compared to agricultural pesticides, for example. Based on your findings, where do you see the limits of their safety? And what misconceptions do you think the public or regulators may have?
This is actually true. I have received a lot of fan mails that say that, why are you studying this when it's only a drop in the ocean compared to agricultural pesticides? But when we are talking about agricultural pesticides, we have to acknowledge that, well, we have to eat. And unfortunately, with our current Western eating habits, it's not possible to grow enough food with organic farming only. And unfortunately, we have to use pesticides also in the future. However, these domestic insect repellents are used mostly because we don't like mosquitoes or wasps. So this comparison is between real needs and comfort. Of course, mosquitoes transmit serious diseases such as malaria, dengue, and yellow fever, for example, which pose a threat to nearly half of the world population. I'm not saying that there is no place anywhere for these domestic insect repellers, but I think we should really think if we need to use them. And not everyone was too happy with my glyphosate studies either, but that's another story. Also, I want to remind that when we are talking about pollinator or insect decline, there is not only one reason for that. We know that the loss of habitats for pollinators is most likely the biggest reason why pollinator species are going extinction, but they are facing various different stressors, often multiple stressors simultaneously, like pesticides, invasive animal and plant species, pathogens, parasites, climate change, etc. And the allegory death by 1,000 cuts is sometimes used to refer to this situation. I can admit that the use of domestic insect repellers is not the biggest reason why there are less pollinators than a decade ago, but it's one stressor that is very easy to remove if we want that there are pollinator insects also in the future.
One of the things that I found really interesting about your results was that they suggest that the prallethrin vapor didn't deter the bumblebees from approaching the device. What does this imply about the effectiveness of repellents versus their unintended ecological costs?
Actually, our results didn't suggest that, but few earlier studies did. Although my own very non-scientific observations during the experiment show that wild bumblebees did not avoid the cover area. I had chosen the exposure zone so that there was as few flowers as possible, but there was still some inside the thermocells covered zone, and there were lots of bumblebees visiting them. I'm sorry, wild bumblebees. But this is the problem with these volatilizing repellers. For example, if you have to get rid of wasp hive for some reason, and you are using the spray bottle containing prallethrin or some other insecticide, and you spray the insecticide straight to the hive, the risk for non-target insects it's minimal. And with these volatilizing repellers, you do not choose which insects are exposed. And that was actually the reason why we wanted to study this.
So looking ahead, what kinds of alternatives, product redesigns, or maybe usage guidelines could reduce risk to pollinators while still meeting human needs for insect control in their homes and gardens?
Well, as I said earlier, I'm not completely against these repellers or repellents, but I believe that everyone should know and acknowledge that these repellents do not only repel mosquitoes, but they are toxic, and they are toxic for other non-target insects as well. Nowadays, the manual of ThermaCell says that it is toxic for bees and you should not use it near hives or in nature. And I think that's a good thing. I'm not saying that we should ban all these repellents because I can see that there is maybe some time and place to use them. And at least in Finland, you are not allowed to use Thermacell outside your own garden, but unfortunately people are using them in nature as well. My latest article got a lot of media attention, and I really hope that people will consider when, where, and if they still want to use those repellents.
So in all your time working with bees and in biodiversity, has there been a discovery or some other part of your work that has given you hope or made you feel like you were making a difference?
Yes, actually. While I was writing my doctoral thesis, I visited many scientific conferences, but I also attend as a speaker in many public events. And for some unknown reason, I was asked for many events for children. And this was weird because I don't really look like a traditional environmentalist or behave like a school teacher. I have a bad habit of swearing a lot. But in my opinion, kids were the best audience because they were really interested in bees and biodiversity. They asked much better and harder questions than academic audience, and they really knew a lot and they wanted to learn more. I really hope that they will keep that attitude, and I believe that they will make world better place in the future. And this was something I was very happy about.
A dead bee is obvious. A disoriented one just disappears. And when workers vanish, the colony loses food, loses stability, and over time can lose its ability to produce new queens. That's how a nest quietly fades. It's also worth remembering that this isn't a farm chemical sprayed across acres of crops. It's a household repellent, the kind people use on patios, in gardens, or while camping. That means bees may encounter these vapors in unpredictable ways as they forage through our shared spaces. Pollinators are already juggling a long list of stressors: habitat loss, climate change, pathogens, invasive species, not to mention those agricultural pesticides. But this is one stressor we actually have some control over. Understanding how everyday products affect bees gives us a chance to make those choices that lighten their load, not add to it. Thank you, Kimmo, for being such a fun and educational guest. Dear listeners, if this episode made you think, can I ask you to please share it with an outdoor-loving friend? Your support doesn't only help the show grow, but our wild bees as well. Until next time, enjoy nature, even the bitey bits.